Hey everyone, what's up? Welcome back to the channel. Engineering is all about using brain power to solve real-world problems, and it's way more exciting than it sounds. Trust me. Think of it like this. Engineers are the builders of our world, right? But even the best builders need a blueprint, a plan. Engineers use their tools to make smart decisions, optimize everything, and find the best solutions, whether it's for a massive construction project, a super complex supply chain, or even figuring out the fastest way to get pizza delivered. We're talking about making things faster, cheaper, and more efficient. And who doesn't love that, right? So, buckle up, because we're about to explore 10 concepts that are changing the game in operations research and engineering. Let's do this. First up, we've got linear programming, and don't let the name fool you. It can solve some seriously complex problems. Imagine you're an engineer designing a skyscraper, and you need to figure out the perfect amount of concrete and steel to use. You want it strong, obviously, but you also don't want to waste materials or break the bank, right? That's where linear programming swoops in to save the day. It's like this. You plug in all your constraints, like the strength you need, the cost of materials, the building codes, all that jazz, and boom! Linear programming crunches the numbers and gives you the optimal solution. It's like having a magic calculator that tells you exactly how much of everything to use to make your skyscraper super strong and cost-effective. This isn't just for buildings, though. It's used in everything from manufacturing to finance, and it's all about finding the best solution within certain limits. Pretty cool, huh? Now, let's talk about integer programming, the superhero, when it comes to dealing with whole numbers. Integer programming is like the ultimate planner for all those situations where you can't have fractions. Say you're an engineer scheduling shifts for a factory. You've got different workers with different skills, different production targets to hit, and you've got to do it all while minimizing costs. Integer programming comes in clutch, finding the best possible schedule that fits all those constraints. No fractions allowed. It's like a giant Sudoku puzzle, but instead of numbers, you're optimizing production schedules, transportation routes, or anything that requires whole number solutions. It's all about finding those perfect whole number solutions that make everything run smoothly. All right, let's talk about getting things from point A to point B in the most efficient way possible. That's where network flow analysis comes in, and it's basically the science of optimization when it comes to anything that flows through a network. Think about traffic flow, oil pipelines, the internet, all those interconnected systems. Network flow analysis helps us figure out how to get the most flow through those networks without any bottlenecks or traffic jams. It's like having a bird's eye view of the entire system, and you can see where the weak points are, where the traffic is getting jammed up, and how to optimize the whole thing. Whether you're designing a new transportation system or optimizing the flow of data through a network, this is the tool that keeps things moving smoothly. Okay, let's be real. Nobody likes waiting in line, right? Whether you're stuck in traffic, waiting for a customer service rep, or just hanging out in line at the grocery store, it's the worst. That's where queuing theory comes in. It's basically the science of waiting in line, and it helps us understand and optimize those queues to make them as painless as possible. By analyzing things like arrival rates, service times, and the number of servers, queuing theory can help us figure out how to reduce wait times, minimize costs, and keep everyone happy. Think about it. Amusement parks use this stuff to figure out how to manage lines for rides. Call centers use it to determine how many operators they need, and even hospitals use it to optimize patient flow in the emergency room. So, next time you're stuck in a surprisingly fast-moving line, you can thank queuing theory. All right, engineers, let's talk about simulations. And no, I'm not talking about those super realistic video games. I'm talking about simulation modeling, the ultimate what-if tool. Imagine this. You're designing a new manufacturing plant, and you want to see how different layouts, production schedules, and staffing levels will affect efficiency. Instead of building the actual plant and testing it out in the real world, which would be crazy expensive and time-consuming, you can create a virtual model of it using simulation software. You can run all sorts of scenarios, tweak different variables, and see how the system performs under different conditions. Simulation modeling is used everywhere from healthcare to finance to transportation to design and optimize all sorts of complex systems. It's like having a superpower that lets you see into the future and make better decisions. Life is full of tough choices, right? And when you're an engineer, those choices can have some serious consequences. That's where decision analysis comes in and helps you weigh your options, assess risks, and make the best possible choice when the stakes are high. Think of it like this. You're working on a big project, and you've got to decide between two different designs. Both have their pros and cons, and there's a lot of uncertainty involved. Decision analysis helps you break down the problem, identify the key factors, and assign probabilities to different outcomes. It's like a structured way to think through all the possibilities and make the smartest decision, even when you're dealing with incomplete information. This stuff is used everywhere, from business to healthcare to the military, to help people make tough calls when it really matters. Okay, let's talk about competition. Whether you're competing for contracts, resources, or just bragging rights, you need to know how to play the game. And that's where game theory comes in. It's about understanding how different players will act in strategic situations and using that knowledge to your advantage. Imagine you're bidding on a big construction project. You don't know what the other bidders are going to offer, but you can use game theory to analyze their potential strategies and come up with a bid that gives you the best chance of winning. It's like a game of chess, but instead of moving pieces on a board, you're making strategic decisions that can make or break your success. Game theory is used in everything from economics to politics to, yes, even actual game design. It's all about thinking ahead, anticipating your opponent's moves, and coming out on top. Let's talk about inventory, because nobody likes having too much or too little of anything. That's where inventory control comes in. It's the art and science of finding that sweet spot between having enough inventory on hand to meet demand without having so much that it's costing you an arm and a leg. Think about it. If you're a manufacturer, you need raw materials to make your products, but storing those materials costs money, and if you have too much on hand, you're tying up valuable capital. On the other hand, if you run out of materials, you're in big trouble, right? Inventory control helps you find that perfect balance by analyzing demand patterns, lead times, storage costs, and all sorts of other factors. It's like having a crystal ball that tells you exactly how much inventory to order and when to order it so you can keep your production running smoothly without breaking the bank. All right, let's get a bit technical here and talk about Markov processes. Basically, a Markov process is a way of modeling systems that change over time, where the future state of the system only depends on the present state, not on how it got there. Think about it like this. Imagine you're tracking the weather. A simple Markov model might say that if it's sunny today, there's a 70% chance it'll be sunny tomorrow, a 20% chance of clouds, and a 10% chance of rain. The future weather depends on the current weather, not on what the weather was like yesterday or last week. Markov processes are used in all sorts of fields, from finance to physics to engineering, to model things like stock prices, machine breakdowns, and even the spread of diseases. It's like having a glimpse of the future to understand how systems are likely to behave over time. All right, engineers, let's talk about project management, because we all know that big projects can quickly turn into giant headaches without proper planning. That's where project scheduling techniques like the critical path method, or CPM, and the program evaluation and review technique, or PERT, come in. These tools help you break down complex projects into smaller, more manageable tasks, figure out which tasks are critical to the overall timeline, and identify potential bottlenecks before they become major problems. Think of it like building a house. You wouldn't start building the walls before you lay the foundation, right? CPM and PERT help you figure out the order in which tasks need to be completed, how long each task will take, and how much flexibility you have in the schedule. They're essential tools for managing large-scale engineering projects, ensuring that everything stays on track and within budget. So there you have it, the top 10 game-changing concepts in engineering. From optimizing resources to making tough decisions to predicting the future, these tools are changing the way engineers approach problems and design solutions. And the best part? This is just the tip of the iceberg. There's a whole world out there waiting to be explored. And it's all about using the power of math and logic to make the world a better, more efficient, and more awesome place. So if you're excited about the possibilities of using your brain power to solve real-world problems, then definitely dive deeper into the world of operations research. Trust me, it's way more exciting than it sounds. Until next time, keep those brains engaged, and I'll see you in the next video.